Are we witnessing the rise of humanoid robots? Or just the rise of humanoid robot hype? And what's really determining the direction of this entire industry? Right now, robotics companies around the world are racing toward one goal: to be the first to convince the public and investors that humanoid robots are almost ready. But is this race really about solving real-world problems? Or is it about winning attention, securing funding, and claiming future market share? What is the true cost of a humanoid robot workforce? And is the technology even remotely ready for mass production? I'm Alina, and this is Above the Machine. Let's be honest, a lot of robotics demos look incredible, with marching formations, synchronized dances, acrobatic flips, and glamorous warehouse shots. But these routines create an illusion of capability. What we're seeing is choreography, a planned sequence designed to look natural, even though everything is controlled: the lighting, the environment, the timing, the object placement. These displays can be impressive. They can be innovative, but they are not proof of real-world, practical capabilities. Let's run a quick thought experiment. Imagine a company called NeoWorks Logistics. They decide to replace 100 human workers with 100 humanoid robots at $35,000 per unit. That's $3.5 million upfront, before the robots even start working. But the real cost comes after installation. Robots need charging cycles, which means only half of them are available at any given time. They need calibration, software updates, safety checks, and round-the-clock supervision, which means hiring 5 to 10 highly trained technicians. And just like any machine pushed to its limit, they break down. Parts wear out, components fail, diagnostics take time. Every repair adds to the bill. With humans, a bad day means they come back tomorrow. With robots, a bad day means parts, downtime, or a full unit replacement. A robot workforce doesn't eliminate labour costs. It simply shifts costs into engineering, maintenance, and non-stop oversight. Now, to be fair, there is real progress happening in robotic hands, and it deserves recognition. Companies like Shadow Robot have developed extremely dexterous research hands. Sanctuary AI has built 21 degree of freedom hands capable of in-hand manipulation. New tactile sensing systems, like the F-TAC hand, are pushing precision forward. And labs around the world are exploring multi-fingered designs with increasing finesse. These achievements are real. The world is moving closer to human-like manipulation. But most of these hands live in controlled labs, not chaotic factories. They're fragile, they're expensive, and they don't survive unpredictable, high-variation environments. No existing robotic hand matches the combined versatility of a human hand, plus the arm, the shoulder, and the whole body coordination behind it. Progress is happening, but reliability, affordability, and scalable integration? We're nowhere near that milestone. And therein lies a major challenge: simulating full body dexterity. A hand does not function on its own. A carpenter using a hammer isn't just using their hand. They're relying on their wrists, their arms, their shoulders, their balance, their posture, and years of muscle memory. A dancer can carry groceries up the stairs, then perform a delicate routine. A surgeon can lift heavy equipment, then execute movements measured in fractions of a millimetre. The same body, a single integrated system. Humanoid robots today cannot replicate this versatility. They can perform specific tasks under ideal conditions. But general-purpose dexterity, the ability to do anything a human can do, remains out of reach. Because the challenge isn't building a robot that can do something. The challenge is building a robot that can do anything. But technology is just a tool, and tools have always been shaped by human necessity. The internet has not only become a global library, it became a social media machine because humans wanted connection. It became an e-commerce empire because humans wanted convenience. Robotics will follow the same rules. The future won't be decided by flashy demos or hype cycles. It will be decided by what humans actually need. Fortunately, there are places where humanoid robots make sense today. High-risk environments, heavy industrial zones, hazardous cleanup, disaster areas, nuclear facilities, deep-sea infrastructure, places humans shouldn't go. In these scenarios, the limitations of dexterity matter less than the advantage of durability. And this is likely where humanoids will first find real traction. But outside of dangerous or repetitive tasks, the story changes. Robots still struggle in unstructured environments, chaotic settings, delicate manipulation tasks, and anything requiring social judgment or improvisation. Even the world's leading roboticists say the same thing. The technology is improving, but nowhere near general-purpose readiness. Right now, robotics development is slow and expensive. Each prototype is a physical iteration. Every improvement requires more materials, more testing, and more waste. But with breakthroughs in quantum computing or next-generation simulation platforms, the process could compress decades of experimentation into hours. To build machines that match or outperform human capabilities, we won't just need better robotics, we'll need better computational tools. Humanoid robots will change the world someday, but not because companies promise it, and not because investors demand it. They will change the world when they can work as reliably, affordably, and safely as humans do today. And we're not there yet. Until then, the human body is still the most capable, adaptable, and efficient machine ever built. I'm Alina, and this is Above the Machine. Stay curious.